Audio Jungle. Audio Jungle.
Right. Question is very special problem, and here the question is draw F sub D and BMD for the single side overhanging beam subjected to loading as shown below. Now beam is now beam is something like this. Now, and it is single side overhanging. One side, another side it is overhanging. And take point here. We have to take point B. Here we have point C. Point and all right. Also, I'll show can show the distance here. 2 meter, nothing. 1 meter, and this is also 1 meter here. Right? This 1 meter, and this distance is nothing but right. This is the dimension. Now we'll give all the loading here. After the loading A to B, we can show A to B. This A to B is nothing but UDL load. A to B have UDL load. And another section we have here at point C, this type of load called as a bracket. This type of load called as bracket load. Bracket load is acting Newton. This dimension here it is given 1 meter. This dimension here is given how much? Right. Now next we have another load called load here, and this is intensity here. Intensity much 30 Newton, and here intensity much everything I have given here, all the dimension in this type of beam called UDL, type of beam called uniformly uniform varying. Both have the same unit, Newton per meter, are the same unit. Okay, intensity I have shown you 30 kilonewton for UVL, 30 kilonewton per meter, and for UDL it is 20 kilo. Right now, so before going to start this, we all are aware with this UDL how to see in short. Again, I will show you for UDL and UVL how to go for the calculation. Suppose if you check this UDL I have taken for AB section, this AB section, the AB section, and here this dimension is nothing but 2 meter, and here the UVL is acting for DE section. DE section, nothing but again, right? To check, this is what UDL acting here downward, and UVL also acting very important. Intensity of this load is given 20 kilonewton per meter, and here it is right. Now I already explained about UDL. You will need to see here. So for the UDL, how to convert into point load? It will be as it is E section. The half of AB section is nothing but 1 meter here, and this is where is mid. This is the mid. How to make the concentrated load 20 kilonewton per meter? How many meters? 2 meters. So 20 into 2 becomes 40 Newton acting at mid of that. This is the mid. Okay. All right. Now coming to the UVL now, same thing we have to do for the UVL also, but calculation method will, we can say is the DE. Now, so total load, how to calculate total load will be, see, this is the one kind of triangle, right? It's a of triangle. So triangle area formula we have to apply, one base into height. What is height? It is total load you have to calculate for the UVL. That is area of the triangle 1 by 2 base into height is nothing but 30 kilo. Cancel out. So now this is, now you should aware with this. Suppose this is the triangle, and for the triangle, if you want to find the centroid of this triangle, I just want to show simple triangle here. Now For this triangle, suppose here CGB. So, and the whole distance, this is nothing but, so if you want to get the right location from this side, it h by 3, this side nothing but, so the total load will be acting at the CG of this circle, CG of this triangle, depends from which side you want to take the distance. Suppose from D side if you write, then it is 2h by 3, and from this side if you want to write, h by 3. Your total load will be acting at the centroid of this triangle. That is, always remember, this calculation will continuous whenever it is required. Just techniques I have, you will be aware with. Now we know to solve this problem, our first step is what? To get reaction force. So now we'll go for the first step. Step 1. What is the step 1? It's nothing but calculation of reaction forces. Where are the reaction forces? Is Ra and is Rd, right? Ra and Rd. We need to calculate Ra and, how to calculate that? We have equilibrium equation. What are the equilibrium equation? Number 1, taking moment at any points, can take moment at point A here. Taking moment at point A must be equal to, okay, this is the first equilibrium equation. Second equilibrium equation, summation of forces in vertical direction, y direction, 0. Two equation you have to use, equilibrium equation. First we'll take the moment about, you can write taking moment, taking moment about point A. Now you see, now you are master in the action calculations. You can see the moment how to get it. Because of this UDL will get, because of this obviously UVL will also have. So I will replace all the loads in point load, so it will be very easy. So first UDL I will replace, dimension I will, for the beam I will show the dimension. Have RA, and here we have point B, here we have, here we have. Now we'll replace all the loads, convert point load. AB we have a UDL. What is the total UDL? It is 20 into 240 kilo. And where it will be acting? It will be acting at mid. So I can say 40 kilonewton is what acting, and it's meter. Then is the another distance, it is 1 meter. Then you 1 meter. And point C. If you see, now talk about the, this is called bracket load. So about this bracket load, if you see, this load is what acting 40 kilonewton at this end. You can shift this load at this point. Okay, this point 1. This is the point exactly at 90 degree. It is a joint base. It is joint. It is fixed. Okay, so not get any moment here at point 6 only. For that reason, whatever the 40 kilonewton load we have, we can shift at point 2. You shift point 2, then it will be something like this. But 40 kilonewton will give the moment also about point 2. What will be the moment? 40 into this perpendicular distance. This is the perpendicular distance, 0.5. So 40 into 0.5 will give the moment also about point 2. Point 2 in the sense it is, so this 40 kilonewton you have to shift at point C. So first you shift that 40 kilonewton exactly at point C. Now this is the 40 kilonewton. It is But this type of bracket load always generate moment also for t into zero point 0.5, because this will be the perpendicular. You are taking moment about zero point 0.2 or point C, because C and 2 both points are same, because the action line is what same. See the action line, if you draw, and C and 2 points both are on the same line, you can take moment about C or 2, meaning is same. So 40 kilonewton into zero point 0.5 will give the moment. So 40 into zero point 0.5, and that will give clockwise moment. By, you can see the diagram, you will understand. See this force, and this is the point. If you draw the circle, I told you how to get check clockwise or anti-clockwise, so it is clockwise. 40 into zero point 0.5, right? 40 into zero point 0.5 is nothing but 20 kilo. That is the moment. So always remember, bracket load will be replaced by force and moment. See, force is what acting at this end. At point 1 force is acting, but this force you can shift at point 2, because it is fixed joint. It is fixed joint. There is no moment at point 2. It is fixed one only. So that's the reason it is rigid body. You can, whatever the load at point 1, it can shift at point 2 also. So now your force will be shifted here. Now what is this distance? This distance, if you check between C and D, it's 1 meter. 1 meter here, 1 meter. And now also you can UVL load also you can transfer in concentrated loads. Concentrated load will be 30 kilonewton, and from this end if you want to calculate the location where it will act, like here it will be acting at mid, where it will be acting, it is 2h by 3. Okay, 2h, what is h? H is nothing but 2 meter, divided by 3 is meter, the distance. So add 4 by 3. The whole distance is nothing. The whole distance is nothing but 2 meter. But to check 4 by 3 is nothing but, I think it is by 1.3. 1.33. 1.33 will be acting somewhere. The 1.3 there, and what is the total load? It will be, now it, right here you just correct one thing. Just I got made mistake. See, because this side area is what more, mass concentration will be more this, but this side area is what more. So CG location will be nearer to this side. Why? Because this side area is more, so mass will be more, particles will be, are talking about the body also. Okay, so this triangle is what actually horizontal. What, because of that only I got confused. Generally, we'll draw triangle something like this for the triangle. So always remember, if you, this is the triangle, so your height is what? Suppose this is the height h, the height h. So because downside more area we have broad area, so CG will be nearer this side. So this side CG is nothing but h by 3, and this side it is 2h by 3. I made mistake. Just opposite I have horizontal triangle, no? So I got confused. Please correct this. Here just a small correction we have. This side it is h by 3. Okay, this side it will be h by 3, and this side it will be, and this side it will be h. Please correct this. So now if you want to check location from D, you can write location from D, so it will be h by, please correct it. Please correct this, h by 3. So it's nothing
So
but,
it's not 2h by 3. It's only h by 3, no?
yeah, it's h by 3, because see, generally, like how to go for the, I mean, general idea. Even though we don't know the formula, then how we'll guess the CG location? So CG is the centroid of the mass center, a centroid of the mass base of the body. So where the mass particles are more and more, that side CG will be shifted. If you see this side, it's a broader, more and more area we have this side, so obviously CG will be nearer from this side. So I told you, like generally we are going through this type of triangle. So it is very clear now. Okay, downside it is h by 3 and upper side 2h. But it was horizontal triangle, so I got confused. But anyway, you correct it. So from this end, CG location is h by 3, and from this side it is 2h by 3. So it's a small correction. You please correct it. This is nothing but 2 by 3. Nothing but right. And small correction. Now coming to this, so 2 by 3. Here also you need to correct. Rest are all are correct. So it's nothing but 2 by 3. But 2 by can convert 0.66 meter also. It's a 2 by 3. All right. Now I'm going to just find the moment first. So what I will write, that is nothing but summation of moment point A is equal to 0. Now I will write moment equation. What I will get, see, 40 kilonewton. It will give clockwise moment. So 40 into 1. Similarly, this 40 kilonewton also will give the clockwise 40 into what is the distance, 3 meter, right? 40 into 3 will get here, right? Now we are having here this 20 kilometer, which is clockwise moment, so it will be added directly. For the moment it is already moment, so we do not have to multiply any distance, and we have to check the nature of the moment. It is clockwise, you just add. If it is anti-clockwise, you can subtract here. Now plus, because of this 30 kilonewton also will have a moment. And what is the total distance? It is 1 meter, 1 meter, 1 meter, 1 meter, 4 meter, plus 2 by 3. Plus 2 by 3, if you solve 2 by 3, it is nearby 0.6, 0.6, 4.30 into 4.6 minus. Now this RD will give anti-clockwise moment about A. So RD into total distance 1 meter, 1, 2, 3, and RD into 4. Now find what is RD. Quick do it. RD is nothing but it. RD is nothing but it. The first equilibrium equation you have used and got. RD is the second equilibrium equation. Summation of all forces in y direction will be 0. So all upward forces will be positive and all downward forces negative. All upward forces RA and RD is equal to downward forces. Only force you need to write. So 40, 20, and 30. And now you can get where it is RA. What? 20 minus how much it is? How much it is?
40, 20,
The 40 and 40.
10. Yeah.
The 40. Again back. 40, 30. Take this 110. Right. So we got RA kilonewton, got RD. Now our problem is what? Almost solved. We got reaction force. Now we'll simple. We have to perform like we already have done calculation of shear force. We'll go for the calculation of shear. Calculation of shear force. So for going calculation of shear force, have beam. I can draw the beam RA. Here it's here we can E, and this is called E. Right. So only we need to indicate the forces. So RA we have just now we got. RA is nothing but 30 kilonewton just now we got, and RD we got 80 kilonewton. See, this was 40 kilonewton if I'm right, and this also 40 kilonewton, and here it is 30 kilonewton, right? The 30 kilonewton, and this is also, and we have moment, but here we are going for calculation only shear force, so moment is not required at all. Okay, anyway, now so we have UDL. Okay, we have UDL, and this UDL I have shown you concentrated load. So even though if you want you can show concentrated load, otherwise, because we have to write left all just before and just after forces I need to write, so better I will show the UDL part. It will be more better, because previous few problems I had solved and I shown UDL only. So you go in that way. If once you will be very perfect, then without drawing beam also you can easily understand what will be the shear force there. Okay, so this is nothing but 20 kilonewton meter. Okay, and right, and here we can say this is our UVL load. Doesn't matter, total 30 kilonewton you need to remember, no issue. And here also you can remember the total concentrated load will be 40 kilonewton. That also perfect, no problem. This is 1 meter, this is 1 meter, total UDL is meter. This is nothing but 1 meter, this is nothing but 1 meter, and this is nothing but 2. All are perfect, no issue. Now we'll write the forces. Okay, so how to start this? I told you just before point, this is point A, hence just before it is 0 0, just after it is 1 1. Then similarly we can say here this is the 2 2. Then we can take here also we have load, this is 3 3, this is 4 4, and here we can just before this we can write 5 5, and here we can write 6, right? All right, and we can go for 7 7. Very easy. Now we can go for the calculation. So as I told you, F11 F00, which is just before the beam, so obviously load will be 0. Then we can go F11, so upward force RA will be considered, so it is upward, hence it is positive. Then we can go F22, so RA is nothing but 30 kilonewton, but if you check UDL, total UDL is acting in downward direction 40, so it's nothing but minus 10. Right, now coming to F33, so F33, between 2 and 3 there is no force, so it is same minus 10 kilonewton. F44, once you go for the F44, then this 40 kilonewton will be considered, which is downward, so it is minus 10 minus 40 becomes 50 kilonewton. Then we'll go F55, so between 4 4 and 5 5 there is no load, so it is similar value like 50, right? Coming to the 6 6, to talk about 6 6 load. So once you reach to 6 6, then RD will be considered, and that RD is what in upward direction, hence plus becomes 30 kilo. Now coming to the 7 7 F 7 7, 30 kilonewton, and total UVL value if you check, it is nothing but 30 kilonewton, which is downward, it becomes 0. I also told you just before the beam and just after the beam force should be 0, and you are getting that. It means all the calculation what you have done, it is correct. This is the checking process actually. Okay, now forces you have done, now you are going to draw for the SFD. huh? So if you are going to go for draw shear force diagram, so roughly you have to draw the beam here, so it will be easy for you also. Okay, and then you extend, this is the RA, and somewhere here this is nothing but what is the point? Somewhere it is nothing but the point was B, if I'm not wrong. Yeah, somewhere here this is C, somewhere here this is nothing but RD, and somewhere here it is nothing but P. All points you need to extend downside. You have to extend something like this. All points you need to extend something like this. Write the value also. It is 80 kilonewton. It is 30 kilonewton. At point C, 40 kilonewton. Obviously, somewhere here, because we can show this UVL is acting, and similarly we have,
Sir, is the other way around. RD is 30 and RA is 80.
okay, RA is 30 and RD is 80, right? Let me check. RD is 80, RA is 30.
Yeah, it's the other way around.
Then it
Wait,
is correct, no? RA is 30 and RD is 80. RA is 30 and RD is 80. Check it.
so can you go back to that where summation MA is equal to 0?
Here we had calculated RD is equal to 80 kilonewton.
RD is 80, then RA is 30.
Uh,
Correct, sir.
RA is 30. Right. So UDL I have shown here, but resultant force you can write, because this UDL is 20 kilonewton per meter and total distance is nothing but 2. So this will be 1 meter and this will be 1 meter. Here it is nothing but 40. Similarly, this is nothing but UVL is 30 kilonewton per meter, and here the total load will be acting. So total load we had calculated 1 by 2 base into height. Okay? So total load was 30 kilonewton, right? All right. Now it is done. Now we can draw the reference line here. This is the reference line now. For this particular reference line, you just start from this first one. It was just before RA, it was 0, 0. So it is starting from 0, 0. This is the 0, 0. Just after RA means it was 30 kilonewton, which was positive. So we'll go in upward direction, just positive value. So we'll go in upward direction. And this is value is nothing but 30 kilonewton. Right. Always remember, upward is nothing but positive and downward is nothing but negative. Just say this is the reference point 0, 0. Okay. Check just before B. What was the just before B? It was nothing but just before B was uh, 2, you can say, just before B, because at B we do not have any force. So exactly at 2, 2, it is nothing but minus 10. So B means minus 10 means somewhere here. This is minus 10. So don't write minus, because downside itself it is meaning is minus only. Okay. Then what is the C? So between B and C we do not have any force. So this will also be 10. You can check here. 3, 3 also minus 10. So you can move this side, because this value is what here also you can. This is the 10. Now RD, we need to reach RD, where RD is there, then 5, 5 value is there. So, and before 5, 5, 4, 4 we have, sorry, 4, 4. So after 3, 3 minus 10, then I F4, 4, it is minus 50 kilonewton. It is minus 50 kilonewton. It is minus 50 kilonewton. So 3, 3 is just before and after. So after and before will be on the same line. So 50 will come here. This is 10. So I can consider this is now 50. I can consider this is now 50. This is the 50 for C. For C. Okay. Now coming to the 5, 5. If you check between 4, 4 and 5, 5, there is no load. So I can take Here also this is 50 kilonewton. And just after rd it is 6 what is the 6 30, which is nothing but positive. So 30, which is nothing but positive, so I can say this is positive. And then if you reach 7 it becomes 0. Since you reached here, again it's all the lines you have to match. And always remember, because we are drawing SFD shear force diagram here, it is shear force diagram. So for the shear force, if we are checking it is UDL, the UDL will be drawn by inclined line. So we can draw inclined line here. This is the UDL. Okay, in between B and C there is no UDL UVL, not any load is there. It's considered as a point load. So for the point load we can draw horizontal line. So this will be horizontal line now, like this. Between at point C, just before it was 10 kilonewton, but just after 10, just after C, 40 Newton will also consider. 40 Newton is acting downward. It is already 10 negative. So minus 10 and minus 40, it becomes minus 50. So 10 and 50 will have to match. It is a straight line because it's a point load. Okay. Now you check C and D, in between there is no force. If there is no force between C and D, then you have to draw by the horizontal line, something like, okay. And check just RD, just before point D it was 50 kilonewton negative, and just after D it becomes 30 positive. Okay, just after D it becomes 30 positive. So we can show this line. This line need to again between D and E, this is UVL. So for shear force diagram, I already explained. For shear force diagram, if it is UVL, then we have to draw parabola. We have to draw parabola, right? So it's nothing but something like this. Huh? This is nothing but parabola. For UVL, we have to draw parabola, right? Now this shear force diagram is what drawn here. Now we have to show hash line here, something like this, be more clear. So this is the shear force diagram. Here we got, always remember upper side it must be positive. So just say positive. This is what negative, what positive. All done. Now we have to draw bending moment diagram. Draw bending moment diagram now. Okay. So what is the beam? The beam is similar. So just roughly you have to draw now. This is the one support here, and this is the another support here. This is nothing but RA. You had calculated this value, it was 30 kilonewton. RD, you had calculated 80 kilonewton. Okay, here if you see, this is nothing but B, and here this is nothing but C, this is D, and this is what E, right? Now if you check, this is nothing but UDL, and here we have bracket load. We had converted bracket load into point load, and one moment we got, and here this is what UVL, uniformly varying, right? If you check the intensity of this UDL, it was 20 kilonewton per meter and it was 30 kilonewton meter, right? Dimension is very important because you are going to write the moment now. So this is 1 meter. Here a total UDL will be acting 40 kilonewton and this will be 1 meter. Total is 2 meter, right? This is 1 meter. This is 1 meter. Total is 2 meter here, right? If you check total load of UVL will be 30 kilonewton base into height. To cancel out, I told you how to write the total load, and this distance will be h by 3, which is nothing but 2 by 3. 2 by 3 meter. Anyway, we'll solve that. Now we are going for the calculation of moment. Calculation of moment. So as I told you, the property of beam already I had explained. End points always moment will be 0. You can prove also, and many times I have proved like A and E, and you also can prove, you will get that moment will be 0. Whenever you will calculate, it will be 0. So no need to calculate. Now we are going to calculate moment for the uh, point A we have calculated. Will go for the moment at point B. So it is nothing but for moment at point B, it is RA. It is nothing but RA into perpendicular distance 2 minus this UDL is 40 into 1, because UDL will give an anti-clockwise moment. So RA is nothing but 30 into 2 minus 40 into 1. It is nothing but 20 kilonewton. This is MB. Similarly, we can write MC, moment at point C. So RA is nothing but 30. Clockwise moment will give, RA will give clockwise moment. 30 into total distance is nothing but 3 minus UDL will give 40 into what is the perpendicular distance, 1 into 1 plus 1, that is 2 meter. Okay, 2 meter. Now this is nothing but 90 minus 60. It's nothing but uh, sorry, 80 into 22 is 80. So it is nothing but 10 kilonewton meter. Nothing but 10 kilonewton meter, that is MC. But at MC, if you check, you can say just before, because at C one moment we have, okay, 20 kilonewton. So first we have calculated, that is, here I can take point, I can take 0 0 or not 0 0, or here for the beam you can take like numbering, you can take you can say we just say 1 2 3, I can tell. So here this is nothing but, or do one thing, I'll give the name better, C left side. Okay, C left side, and this is C right side. C right side, west. So if you calculate C left side value, so this value will come. But if you calculate moment at C right side, so right side means once you cross this C, right side means what? You are crossing C. You are going right side. It means you are crossing C. So at C we have a moment 20 kilonewton meter, which is clockwise. So clockwise means it will be plus. So 10 kilonewton already we have. 10 kilonewton will already have, plus that 20 kilonewton will be added because it is clockwise moment. So it is nothing but 30 kilonewton, right? MC. Now we'll go for the moment at point D. So if you calculate moment at point D, then again RA and all value you have to write. So it is RA. RA is nothing but 30 into what is the total distance? 1 plus 1 2 meter plus 1 3 meter, 3 plus 1 4 meter, right? So it becomes RA. For RA it becomes, I'll tell you in both way, I will tell you. So for RA, total distance from D is nothing but 4 meter. So RA 4 meter minus, see this 40 kilonewton will give anti-clockwise moment. So 40 into 1 plus 1 plus 1 means 40 into 3, right? Then we'll see this 40 kilonewton here also acting at point C, also 40 kilonewton acting, which will give anti-clockwise moment. So 40 into, what is the distance? For D it is 1 meter. And at C clockwise 20 kilonewton meter is acting, so that will be added because it's a clockwise moment. What is the MD? See, 330 into 4 120 minus 40 into 3 120. This will be cancel out, minus
minus
40 plus 20, minus 20, right? Minus 20. Or how to calculate moment at D? Here you can check. See, now this is the shortcut. Now you concentrate for this beam, this side beam. If you take this side beam, then use this side, opposite side you just forget. Just like here, you were calculating moment at B, so right side you forget what are the forces, nothing. There is no matter, okay? If you are calculating moment at B, so you will consider only left side value. Right side you will consider there is no beam, nothing is there. Similarly here, if you take right side, so left side you consider 0. If you take right side about D, so what are the forces? Only one force, 30 kilonewton. So 30 kilonewton into what is the distance? It is nothing but uh, 2 by 3, right? 30 kilonewton and 2 by 3, and it will give anti-clockwise moment. So it will be the 30 kilonewton, that is UVL, total load you have calculated, and where it is acting 2 by 3. This distance I told you, this is 2 by 3. So you just multiply by 2 by 3. If you solve this, how much? Minus 20. So both way are correct. It's your choice. You want to write this way or this way, it's your choice only. At each points you have calculated moment. Now we are going to draw bending moment diagram. So drawing, no? We are going to draw bending moment. For that, what we'll do, again we have to, roughly we have to draw the beam and we have to extend. So I can say, suppose this is the beam. Now draw nicely, right? This is RA, and somewhere here this is RD. This is what? E. Somewhere here we can see this is what? B. Each and every points, because we are drawing the bending moment diagram, so we are interested about only moments. So at RA, what moment you have calculated? See, at RA, MA and ME both, MA and ME, here moment is MA, it is 0. Here moment is what? ME, it is 0. Here we have calculated moment MB. What is that moment MB? 20 kilonewton meter, plus means clockwise. So it's a plus clockwise 20 kilonewton. MC, moment at point C. It is left and right, both we have to write. So left side it is 10 kilonewton and right side it is 30 kilonewton. Both moment we have to write. So at C, MC LS left side and MC right side. What is the right side value? It's nothing but 30 kilonewton. It's a 30 kilonewton meter, and it is 20 kilonewton. No, sorry, 10 kilonewton. Left side it is 10 kilonewton. Here this is 10 kilonewton. Left side it is 10 kilonewton, right? It's 10 kilonewton meter. And RD, at point D, what is the moment you have calculated just now? It is minus 20 kilonewton, which means anti-clockwise, which means 20 kilonewton anti-clockwise. No? Now you extend all the points downside, and if you extend all the points something like this. Okay, draw one reference line which is nothing but horizontal line, and this is 0 0. Okay, if you go upward it will be positive, if you go downward it will be negative. Now we'll indicate all the value. At point this A it is 0, at point B it is positive 20 kilonewton, so this is the positive 20 kilo. I must write somewhere clear, is nothing but 20 kilonewton. If you go C, then it is 2 points you have, 2 moment you will get at C. It is 10 kilonewton, so I can say this is the 10 kilonewton meter. But again at C, up left side is 10 kilometer, but right side becomes 30 kilonewton, so you can say this is the 30 kilonewton. At D it becomes anti-clockwise, means minus, so this is my 20 kilonewton meter, and at E it becomes 0. Now we'll meet it. See, it's very simple now. We start from anywhere. You start from 0 to B. Check in 0 to B what we have, it's a UDL. We have UDL, right? And what we have here, it's a UVL. Always remember. So in UDL, if you are going to draw BMD, then if you are going to draw SFD for UDL, it is inclined line. So if it is inclined line for shear force, then for bending moment diagram, one more degree will be added. So it becomes parabola. So you have to draw parabola something like this. See, this is the parabola. Okay. In between B and C, we do not have any UDL, we do not have any force, so it's an inclined line. We have to draw inclined line. Okay. So it will be inclined line something like this. The inclined line now, 10 kilonewton. And 30 kilonewton you have to meet by the straight line, because it's the same point, just left side and right side of the C. So first 10 kilonewton will come, then 30 kilonewton. Okay, because left side is 10 kilonewton and right side means after, left side means before. So first you have to meet with the before point, then you have to go for after, right? 30 kilonewton. Then at D you got anti-clockwise, which is 20 kilonewton meter, and it will be downside because it is anti-clockwise negative. In between C and D you do not have any UDL or something, only point loads we can say. So it will be meet, both points will be connected by this inclined line. So I can take this inclined line something like this. No, not correct. Again we'll try. Right. Now this is D and E. In between D and E, what we have, UVL. So if it is UDL, then parabola for bending moment diagram. But once it is UVL, then cubic will come. Okay. Once cubic will come means in parabola it is 2 degree. So cubic means 3 degree. That means more curvature will come. So more curvature will come, then it will be something like, okay, it will be something like this. This is the more curvature, because it's a cubic. You have to show this is what cubic, right? Like this it will. All the value has been mentioned here, right? We just make a hash line. If it is asked, is there any point of contraflexor? Yes, there is point of contraflexor. What is that? That point of contraflexor is nothing but this is the point of contraflexor. right? Correct. So this is the bending moment, right? All right.